In this topic, we study the Generalized Pareto Distribution, or GPD, which is mainly used to model extreme losses in financial risk management. Instead of modeling the entire dataset, the GPD focuses only on large losses that exceed a chosen threshold. This idea comes from extreme value theory and the Pickens-Balkema-Dehaene theorem, which states that as the threshold becomes large, exceedances converge to a generalized Pareto distribution. The shape parameter J controls tail behavior. When J is greater than 0, the tail is heavy, meaning extreme losses can be very large. When J equals 0, the tail is exponential. When J is less than 0, the distribution has a bounded tail. The second parameter beta is the scale parameter, and it must always be positive. A key intuition is that the GP distribution models the tail much better than the normal distribution. The normal distribution underestimates extreme losses, whereas GPD gives a more realistic tail representation. However, selecting the threshold is important. A low threshold gives more data, but poor tail modeling, while a high threshold improves theory but leaves fewer observations for estimation. This leads to the peak over threshold, or POT method. In this approach, we choose a threshold U and model only the losses above it. The number of exceedances is denoted by N sub U. POT allows us to estimate risk measures like value at risk and expected shortfall using extreme loss data. Value at risk, or VAR, represents the loss level at a chosen confidence level. Expected shortfall, or ES, measures the average loss beyond VAR. It captures the severity of tail losses and is generally considered more informative than VAR.